Great, my video cut out halfway through because memory was filled. So we had to look at 0 and 6 for a point, and we had to defend that that was our smallest value. I also then talked through the next question for 2 minutes, which I'll do again, I guess. So we want to know on what open intervals is it both concave down and increasing. So if we start out for looking where it's increasing, we need the derivative to be larger than 0, which just means we need the derivative, which is this graph here, to be above the x-axis. So that's from 0 to 1, 1 to 4, and 6 to 8. Notice I did not include the 1, the 4, or the 6 because they are equal to 0 there, and that does not actually count as being greater than 0. We also want where it is concave down, which means the second derivative is less than 0. But we don't have the second derivative here. But we can really think that means where is the first derivative decreasing. Decreasing meaning it's actually physically going down. Where is this graph decreasing? Which is actually these two intervals here, from 0 to 1, and then from 3 to 5. So we now have where it's concave down and where it's increasing. But since we want both, we need to see where they overlap. 0 to 1, 0 to 1. 3 to 5 is actually only 3 to 4 in this one up here. And the last question maybe some of you are having is, well, why did we not include the 0 here? Because it is not technically concave down here at the end. It's just like kind of some point, and you need it from both ends, so it doesn't include the 0. I don't think you get marked off if you did have a hard bracket there. I think all that they really care about is 0 to 1 and 3 to 4. Okay, and part D here is where we can actually go through this question without having any knowledge of the ones above it. Another part where you can just do kind of independently on your own. So part D gives us some function g here. It's f of x cubed, and they tell us what f of 3 is. Notice we don't know what f of 3 is. This is only the derivative. And they want us to find the slope of the tangent line to the graph at x equals 3. I know that one. Tangent line. That's good. So if we want a tangent line, we need a, what do I want to write here? Point first and a slope. Well, g is 3, so I know the point is 3. I don't know what the y is, but let's see what g of 3 is. That is f of 3 to the third. They tell us what f of 3 is. To the third, so negative 5 to the third is negative 125 over 8. Okay, so we have a point here. Oh wait, no, that's, I'm going through way too much here. Find the slope of the tangent line to the graph of g. Yeah, maybe that's okay. Not useful information. The x being 3 is the most useful part. But we also need the slope, which is really where this whole question is coming down to. And slope, we need a derivative. So since they give us g of x is here, we need the derivative. Which means if we're taking the derivative of f of x to the third, we're going to need to do a little bit of a chain rule. So that 3 comes down in front, and we still need the derivative here. So now we need to actually evaluate what? I didn't want a tangent line, I just wanted the slope. That's why we didn't need that. So 3 times f of 3 squared f prime of 3. Great. F of 3, we're told here. So it's 3 times negative 5 over 2 squared. F prime of 3, you may think, oh, they don't actually give us that one here. And we don't know what the f function is, but that's okay. We can go up here, and we know that f prime of 3, is 4. So multiplying all these together, we're going to get 3. The 4s are going to go away, right, because it's 2 squared. So that's 25 times 3. 75, and it just wanted the slope here, so we actually did not need that point. Okay, about 10 more minutes to go through that one. Last one, let's see if we can get it done in 10. This one is a question I think we really are going to like to see on our AP. These are great. They give us a differential equation. As soon as we see those, that's what we've been doing for like the past 3 weeks here. Really nice stuff. And it gives us a point here. That's always important to denote what's our point. Notice this is only 2 parts, and it's 9 points going to be all together. Okay, write an equation for the line tangent to the graph. This is where I'm getting a little bit ahead of myself. So this is what I was talking about last time, where we need a point and a slope. Point, they're nice enough to give it to us here. 1, 0. Slope means we need a derivative. Oh, they were just nice enough to give us a derivative here. So let's evaluate this dy dx at the point 1, 0. So that's e to the 0 times 3 minus 6. So we should have negative 3 here as our slope, and that's our point. Y minus 0 equals negative 3x minus 1. And that's a nice equation of a tangent line, but that's not quite enough. Use this tangent line to approximate 1.2. So that's the x value of 1.2. (1.2 minus 1.2). So here we just have negative 0.6. Point breakdown here is properly evaluating this to get negative 3, putting it in the equation, and then getting negative 0.6. 3 nice, easy points here. Part B. This is what they ask for most of these. Find the particular solution. So when we have this derivative that they give to us, we need to separate variables first. Remember, that is not adding or subtracting, that's multiplying and dividing. So we need the y to move over to the left side. So that means we need to divide that e to the y and multiply that dx over. Once we get here, we need to take some integrals. This one on the left is a little tricky, I think, to think about there. You maybe want to write it as e to the negative y. And once we have e to the negative y, you can go through and do a u substitution. And maybe you're starting to realize that if it's just the negative variable, the only thing that really kicks out is a negative sign. So it's negative e to the negative y is what that antiderivative is going to be. If you do not understand that, u sub this, just e to the negative y, you will end up here. And then we have to do the integral over here, which is a little bit more straightforward. That becomes x cubed. This one becomes negative 3x squared, and we need that plus c, of course. Okay, most of the way through it at this point. We need to find out what this constant is. Let's use that 0.10 here and find out what that constant is right away. So if you're plugging in 0 here, that's e to the 0, which is just 1, equals 1 minus 3 plus c. So our constant here is going to be 3. Did I do that right? They're saying I didn't do that right. I think I did that okay. I don't know. I don't really like their work. I think I like it as 3 here, right? Negative 2. Okay, we're back to our equation then. And now we need to solve specifically for the y value here. So I need to move that negative over. So this just becomes e to the negative y. This becomes a plus, 3x squared minus 3. At this point, we need to ln both sides. So we have a negative y equals the ln of all of this. And then we need to negate this again. So it's negative ln. And we're right here. Okay. Oh, I think I see where my mistake was. This is a negative 1, isn't it? So this would be 1. Whoops. Like, I think the answer key's wrong. Yeah. So yeah, that was just a negative 1. That was my fault. Okay, either way, we end up with this whole thing. If you look on the solution manual, they give you some interval. That doesn't matter. What matters is we get to this y equals. Make sure for some point breakdown, 1 point for separation of variables on this step, 2 points for the antiderivatives, so correctly doing both sides, 1 point for that initial condition being used, and 1 point for solving correctly. So even if you're like me and you mess this up, that's only 1 point off. Not so bad. Okay. The AP was supposed to post more practice questions related to what our specific exam will be like. I've yet to find those, or they've yet to post them. So what I've decided to do for us is just we're keep plugging along. So our homework, we're in 2014, 3 through 6. So 4 more questions. I will have these up and posted on Friday. Everyone stay safe, healthy, and I will talk to you all then. Bye.